Imagine stepping onto a prehistoric battlefield. Your heart is pounding against your ribs, your breath is shallow, and your muscles are tensed for action. On the other side of the clearing stands an opposing tribe. They are armed with heavy wooden clubs, sharp flint-tipped spears, and spear throwers capable of launching darts at 90 miles an hour. You are slow, soft-skinned, and completely lack the protective armor of a turtle, a crocodile, or an armadillo. If a single thrown stone or sharp spear strikes your chest or head, your evolutionary journey is instantly over. For millions of years, the human body had only one way to deal with physical threats. We ran away, or we relied on our natural, instinctive reflexes to block the blow with our bare arms. But at some point in our history, we decided to stand our ground. We chose to stop fleeing, and instead, we built a wall that we could carry. The invention of the shield is one of the most transformative, high-stakes breakthroughs in the history of human conflict. It wasn't just a piece of defensive wood or leather. It was a psychological and mechanical shield that cured our primal urge to run, fundamentally reshaping the physics of warfare and laying the foundations for human civilization. So how did ancient humans actually invent the shield? How did they transform raw animal skins and woven reeds into materials as tough as modern plastics? And how did a simple piece of defensive gear completely change how our brains process fear? To understand how we invented the shield, we first have to look at our own biology. Long before we ever picked up a piece of wood or leather to protect ourselves, our bodies already possessed a built-in defensive shield, our forearms. If someone suddenly throws a ball or swings a fist at your face right now, your body will execute a highly coordinated, instinctual reflex known as the startle response. Your shoulders will shrug, your neck will tuck, and your arms will automatically fly upward, crossing in front of your eyes and throat. This is not a conscious decision. It is a primal biological program wired directly into your nervous system. Your forearms are naturally positioned to act as shields, sacrificing themselves to absorb the impact of a blow in order to protect your highly vulnerable brain, eyes, and jugular vein. In fact, our primate relatives, like chimpanzees and gorillas, rely heavily on their thick muscular forearms to block and parry the bites and swings of their rivals during dominance battles. For millions of years of hominid prehistory, our forearms were the only shield we had. But as our ancestors began to develop cognitive intelligence and invent weapons, the physical limits of our forearms became a deadly problem. A human forearm can easily absorb the impact of a low-energy swing from a wooden stick, but it stands absolutely no chance against a sharp, heavy flint-tipped spear or a heavy stone club swung with the full force of an adult male. To survive, early humans had to find a way to project their defensive reflexes outward, extending the protective barrier of their arms. The first step in this defensive revolution was not a full coverage shield, but a simple, elegant tool called a parrying stick. Before we built giant, heavy walls to hide behind, we used highly active, agile, defensive batons. Observed extensively by anthropologists studying indigenous populations in Australia and Africa, the parrying stick was a simple, sturdy wooden club, often slightly curved or thickened in the middle to protect the hand. It required no complex engineering, but it required extraordinary physical skill. When an enemy threw a spear or a stone, a prehistoric warrior would not stand passively behind a wall. Instead, they would track the incoming projectile with their eyes, wait until the absolute last second, and use the parrying stick to physically swat the spear out of the air with a swift, snapping motion of the wrist. It was an active, high-speed game of prehistoric baseball, where your life was on the line with every pitch. The physics of parrying are remarkably elegant. By striking the side of an incoming spear rather than trying to block its tip head-on, you only need a tiny fraction of the force to redirect its path. A small sideways tap can send a lethal, high-speed dart sailing harmlessly past your shoulder. But while the parrying stick was highly efficient and incredibly lightweight, it had one fatal flaw. It required perfect human reflexes. If you misjudged the speed of the spear, or if the enemy threw two spears at the same time, the parrying stick failed and the results were catastrophic. As populations grew and warfare became more frequent and coordinated, the passive, full coverage shield became an absolute evolutionary necessity. Humans had to transition from actively swatting away individual threats to standing passively behind a protective wall. The very first true shields were not made of metal or even solid wood. They were made of raw animal hides. To a modern mind, animal skin sounds soft, flexible, and completely unsuited for stopping a sharp spear or a heavy blow. But ancient humans understood the remarkable material science of rawhide. Rawhide is animal skin that has been scraped clean of meat and hair but has not been tanned. When rawhide is wet, it is highly stretchable and easy to manipulate. Prehistoric shield makers would cut a thick piece of hide from a large animal, like an elk, a bison, or a wild ox. They would stretch this wet hide tightly over a simple frame made of flexible willow branches or a solid wooden spine, and then they would let the sun do the engineering. As wet rawhide dries in the sun, it undergoes a massive physical change. The collagen fibers inside the animal skin begin to contract and shrink, pulling the hide incredibly tight over the wooden frame. As it shrinks, the hide dries into a material that is phenomenally tough, rigid, and highly resilient. This dried rawhide is essentially a prehistoric precursor to modern carbon fiber or high-strength plastics. It is lightweight, but it is structurally so tough that it can easily deflect a stone-tipped arrow or absorb the bone-shattering shock of a wooden club without cracking. In some cultures, they went a step further, using a process called cuir bully, or boiled leather. By gently heating the wet hide in warm water or natural saps before stretching it, they partially broke down the protein fibers, causing the leather to dry even harder and more rigid, resembling a solid sheet of tough, protective plastic. In different parts of the world, humans adapted their shield designs to match the specific threats of their environments and the materials available on the ground. In the reed-filled river valleys of ancient Mesopotamia, Egypt, and Persia, wood was scarce, and animal hides were expensive. So engineers turned to a remarkably abundant, flexible, and lightweight material, wicker. Wicker shields were made by tightly weaving flexible reeds, bamboo, or willow branches together into a dense, solid mat, which was then covered in a thin, protective layer of leather. To a modern soldier, a shield made of woven sticks sounds incredibly flimsy. But the physics of wicker are actually brilliant, behaving remarkably like a modern automotive crumple zone. When an arrow launched from a powerful composite bow hits a solid wooden shield, the wood can crack or split, allowing the arrow to penetrate. But when that same arrow hits a woven wicker shield, the loose, flexible fibers of the reeds shift slightly. This shifting motion absorbs the kinetic energy of the arrow and disperses it across the entire woven network, trapping the arrow point safely inside the woven branches without shattering the shield. It was an incredibly cheap, lightweight, and highly effective defense that allowed massive armies of thousands of soldiers to march long distances across hot deserts without being weighed down by heavy gear. But as human metallurgy advanced and the Bronze and Iron Ages swept across the globe, the nature of weapons changed. Simple stone tips were replaced by heavy bronze swords, solid axes, and metal spearheads. To survive this new era of metal, the shield had to undergo its next massive upgrade, the invention of the metal boss. Before we began covering the entire shield in heavy, expensive metal, ancient armorers focused on protecting the most vulnerable part of the shield, the center, where the hand gripped the wooden handle. To do this, they carved a circular hole in the center of the wooden shield, placed a wooden handle across it, and covered the opening with a heavy, dome-shaped metal cup called a boss, or umbo. The metal boss was a brilliant dual-purpose innovation. First, it protected the user's hand from being crushed by heavy blows directed at the center of the shield. Second, because of its rounded, domed shape, any spear or sword that struck the center of the shield would naturally slide and deflect off the rounded metal surface rather than penetrating. It also turned the shield into an offensive weapon. A soldier could use the heavy, protruding metal dome to smash into an enemy's face or chest during a close-range grapple. But the true peak of ancient shield engineering happened in the Mediterranean, with two revolutionary designs that changed the course of history forever: the Greek hoplon and the Roman scutum. If you watch a modern movie about ancient Greece, you will see warriors carrying giant flat shields and swinging swords with wild individual agility. But the real Greek shield, known as the hoplon or aspis, was designed for a completely different style of warfare. It was a massive, bowl-shaped shield made of thick laminated wood with a slightly curved circular design, faced with a very thin layer of bronze. The hoplon weighed nearly 16 pounds, which is incredibly heavy. If you tried to hold a 16-pound shield by a single central handle for more than 10 minutes, your forearm muscles would quickly fatigue, your wrist would buckle, and you would drop the shield in exhaustion. To solve this weight problem, Greek engineers invented a revolutionary dual-strap system. Instead of a single central handle, they placed a wide metal band called a porpax in the exact center of the shield, through which the soldier would slide his entire forearm. His hand would then grip a leather handle called an antilebe near the outer rim of the shield. This simple change completely shifted the physics of carrying a shield. Instead of your wrist and fingers supporting all the weight, the heavy 16-pound shield was locked securely onto your forearm, shifting the physical burden of the weight to your entire arm, bicep, and shoulder. This allowed a soldier to carry a massive, heavy shield for hours without fatigue. But more importantly, the hoplon was designed to protect the person standing next to you. Because the shield was bowl-shaped and extended far past the left side of the user's body, it naturally covered the unprotected right side of the soldier standing to their left. This was the mechanical foundation of the phalanx formation. In a Greek phalanx, soldiers stood shoulder to shoulder, locking their circular hoplon shields together to form an unbreakable, continuous wall of bronze and wood. You were not fighting as an individual. You were a single interlocking brick in a massive cooperative defensive wall. Your life depended entirely on the shield of the man next to you. It was the ultimate physical expression of human cooperation, turning an entire army into a single, unified organism. A few centuries later, Roman engineers took this cooperative wall concept and redesigned it for extreme mobility, flexibility, and offensive power. They invented the scutum. The scutum was a large curved rectangular shield that wrapped around the soldier's body. But the real engineering genius of the scutum was how it was built. It was made of laminated wood, an early, highly sophisticated form of modern plywood. Roman woodworkers would slice wood into thin, flat strips. They would lay one layer horizontally, glue a second layer on top vertically, and add a third layer horizontally. By arranging the wood grain perpendicular to each other, they created a material that was incredibly light, but structurally phenomenal. Wood naturally splits easily along its grain, but by crossing the grain layers, the scutum became virtually split-proof. It was incredibly tough, flexible, and because of its curved rectangular shape, it offered near-total body coverage. The curved design of the scutum allowed the Romans to execute one of the most famous tactical formations in history, the testudo, or the tortoise. When facing a massive barrage of incoming arrows, a Roman sentry would close ranks. The front row of soldiers would lock their scutum shields together in front, while the rows behind them would raise their curved shields over their heads, locking them together like the overlapping plates of a tortoise shell. Arrows, stones, and spears would rain down on this wooden shell and bounce harmlessly off the curved surface, allowing the soldiers to march forward, completely untouched. It was a highly disciplined, mechanical system that turned a group of individual humans into a mobile, armored fortress. But the deepest impact of the shield wasn't just physical or mechanical, it was psychological. In a raw, primitive state, our natural instinct, when faced with danger, is to run. This is our fight-or-flight response, a deeply hardwired survival mechanism designed to save us from predators. But running in a battle is highly dangerous. It exposes your back, breaks your formation, and leads to mass panic. The shield solved this psychological problem by creating a physical barrier between the human brain and the danger. When a soldier stands behind a solid, heavy shield, their brain registers a profound sense of safety. The visual field is restricted, blocking out the terrifying sight of the approaching enemy, while the solid weight of the wood and leather in their hand reassures their nervous system. The shield allowed humans to quiet their primal flight reflex, stand their ground, and remain disciplined under extreme stress. It turned a chaotic, panic-driven skirmish into an organized, collective action. It built the very concepts of military discipline teamwork, and shared trust that allowed small groups of humans to conquer vast empires. We have built a modern world of ultimate distance where we fight our battles with invisible computer networks, long-range missiles, and drones operated from behind screens. The shield has been replaced by heavy tanks, steel armor plates, and bulletproof glass. We treat these technologies as the pinnacle of modern security, but your ancient hardware still carries the memory of the wooden wall, the natural human instinct to protect ourselves, to shelter under a barrier, and to stand shoulder to shoulder with our tribe is still running in our gene pool. We didn't just invent the shield to survive the weapons of our enemies, we invented it to survive our own fear. Every shield that was ever built, from a simple piece of raw buffalo hide on the plains to the massive bronze hoplon of Greece, was a physical monument to human cooperation. It showed us that we are always stronger when we stand together, lock our defenses, and choose to face the dark as a unified tribe, trusting the person next to us to keep us safe.